All right, so somebody started recording us. Okay. So in this class, we're going to talk about the drainage components and layouts. So the last class, if you see, so the main components are the field system, main system, and the outlet system. And that means if you have, so if you have, let's say this is the field. So if you have, this is the agricultural field. We have a field system which collects the water from the field and dispose it to a main system. So let's say this is the main system. Okay, from field system to main system, and from the main system to, so you need to dispose it off. This is called outlet system. Yeah. So irrespective of whether it's a surface drainage or subsurface drainage, so you would see these three main components. One is the field system. So the main objective of field system is to collect, the water or excess water from the field surface or subsurface, and then it's going to convey it to the main system. So main system, it collects the water from individual layers. So the field system will contains field channels and laterals. Okay, field channels and laterals. Whereas the main system, it's open ditch. Sometimes it could be like a, big pipe drainage. Okay, so large diameter pipe drainage. So the main system collects all water from individual fields and it disposes it out from the field using an outlet system. So as I mentioned, there will be two kind of outlets. So one could be like a gravity outlet and the other one is pump outlet. So you have to decide based on the the drainage base of the sink. Okay, so suppose so the gravity system generally will follow when your drainage base is below, above the drainage base of the sink. So suppose, so this is the your you know the drainage base of the main system. This is the drainage base of the main system, and you want to the drainage base of the outlet, sink system is here. This is the drainage base. So since it is below, so you can use the gravity outlet. This is called the gravity outlet. So whereas if this is the drain, let's say this is the drainage, and this is maybe it's a stream or something where you want to dispose it. Whereas the pump system, what happens, the drainage system will be here, your drainage systems, the drainage base. So this is the, yeah. And your stream might be, at the higher elevation. So in this case, you need to use pump to, dispose the drainage water. This is the drain, this is the stream. That's where there's two systems in place. Okay. So, and also we discussed about why this surface drainage system. So what is the use of surface drainage system? So surface drainage, this system basically to remove excess water. This is to remove excess water on the surface, excess water on this surface, and it contains the shallow drains. Shallow drains. So, and then mostly the water logging problem could be, controlled using surface drainage. Water logging problems or issues could be controlled. So whereas subsurface drainage system, so in case of subsurface drainage system, so it removes the subsurface water or water from the root zone. So that is one. And so the basically you're controlling the water table. Okay, controlling water table, and you're maintaining the salt levels or removing salts from the root zone, and then it contains open ditches. So it could be like a deep ditch, deep open ditches or pipes. Okay, so these are the I mean structurally or the basic difference between the surface and subsurface or drainage systems. So the characteristics of surface drainage system. So it is basically, has I mean the two things. So the first is land forming, and then second is it contains the open drains. So since the objective is to remove the overland flow or excess water on this field, on this surface, so you need to have the surface to be well leveled, okay, and also the slope to be maintained, okay, and leveled and slope to be maintained. So that's why the land forming is important in case of surface drainage system. So once the land forming is done, the next thing is it will have the open drains. So the surface drainage system will contains the shallow open drains. So we're going to see how the land forming is being done in case of surface drainage system. Okay, so let's see the land forming. So it's basically three ways. So one is the bedding. So bedding, land grading, land planing. So these three, things you can see. So in case of bedding, suppose if you have, suppose if you have a field of rectangular piece, let's say. So the bedding will be like you identify some area and take the soil from either side and make a heap. It's not like a steep heap, like it's like a bedding. Okay, so once you make so it looks like this. I'm going to show this kind of cement. Suppose you have like a field. And similarly, the other side. Right, this is the cross-sectional view of the bed. Okay, so if you have, this is the rectangular piece of land. Okay, so what I did was, this is like a, so these are, so from this to this, it's kind of a bed. Okay, similarly from this to this is the bed. Okay, so runoff will, so surface runoff, so from here to here, whatever the water which is falling, and it goes, the other part will go to the other drain. So this is the surface runoff. And the field grade should be this direction. This is the slope. Okay, so similarly other side. So this is the field drain. Okay, and you can see the collector here. So this is called the collector. Okay, so this is the bedding. So bedding, in case of bedding, plowing, we are mostly you plow the land to form a series of low beds separated by these parallel field drains. So these are the field drains, and this is most practicable on flat slopes, which the slope should be, less than 1.5% slope. It is more practicable, and this is the oldest practice. Okay, this is the oldest practice, mostly used for grasslands. If you see, in the grasslands, the huge grasslands, so they look like, some kind of beds, right? Nice beds. So that's the old practice here. And the next is the land grading. The other uh, land forming is, the second is land grading. So look, we are only talking about the surface, characteristics. Okay, so how to make the surface favorable for, resulting the runoff. Okay, so land grading. In case of land grading, mostly will be cutting the, land and filling the land in the other place. Okay, for undulated fields. Suppose if you have a field of like kind of undulations, like this is the uh, okay. If this is the field, um, so here is the cut, and again here is the, so like this. It's going. So this is the initial. So you want to make a regular, grading. Okay. So like I want to use this one. Let's say. So I'm expecting slope. Yeah. So that is the slope I'm expecting. So here, so this I need to cut. This portion I need to cut, and this portion I need to cut, right? And again, this I need to cut. Similarly here, this to be cut, this to be cut, and this to be cut. Okay, so the portion which is been cut, that should be used to fill it. So the fill the other portions. So like this portion will be used, or maybe the other side, this portion will be used to fill this. This portion will be used to fill this. So like this cut fill method will be used to, define a particular grade of, or achieve the particular grade of the land. Okay, so it reduces the number of field drains, and most of the land probably used for, useful for the farming. And if you compare with bedding, this is economical, because the bedding will include a lot of earthing operations, like cutting and scrabbing and all those things. Okay, so whereas in this case, so we know, after having a particular survey, land survey, so we will decide exactly what to be the grade, without taking soil from other places to fill. Okay, so we are not going to get the soil from other place. So the existing soil will be used to, fill the, hills, to fill the falls, and then a proper grade can be achieved. So in this.
Excuse me, sir.
Yeah.
Sir, can you please explain why are we doing like what is this the purpose of this like green thing you are shifting there? So, sir, I couldn't understand it.
Okay. So here the main purpose is to have, the excess water which is on top of this, field surface to be drained. Okay, unless you have a proper grade. Suppose assume that you don't have any grade for this particular case. So what happens is, so when the water falls, so that is going to stay stagnant in the patches. So here if you see, so this maybe it is, you know accumulated here or accumulated here water. So it's not going to be drained. Okay, so in order to have a proper grade, right, so that water can be drained, easily from, this place to, let's say, so from here to here without having any difficulty. So our purpose is to remove the, overland flow. So here in this case, in this situation, if the land has, a lot of undulations. Okay, so in that case, so you will be using the, surveying method to identify where to, cut and where to fill. Okay, so that you will get the, at the end of this operation, so your land, surface will look like this at a particular grade. Okay, this is a smooth surface. You understand?
Yes, sir. Yes, sir. Got it. One more question, sir. What is a grade?
What is the grade?
Yes, sir.
So the grade you are expecting here, for the flat slopes here, this one also for the flat slopes. So mostly the less than 1.5%.
Okay, so sir, grade you mean slope? That is
Yeah, the
grade.
slope. Yeah, land
Okay, okay,
grading. It's a slope.
okay, okay,
Yeah,
sir.
yeah.
Okay.
Okay, so the next is next operation. I mean, these are different cases where you can adopt. The first case is bedding. You can do. It's not that combinations for bedding, and in some cases you may use the land grading. And some cases, suppose you don't need to do much, but you identified some patches left. The grade is good. Suppose you have done this operation. Then after so many years of usage, you may have some kind of patches developed, right, in between. So that's the third case where we call land planing. Called land planing. So in this case, you need not do much operation like cutting and filling. So the simply smoothing of the land surface, right? So like if uh, you can also bring some soil from other places and then put it here, and again fill it here, fill it here, fill it. Once the filling is done, then again use the land leveler to have one pass, and that will give you the smoothness of the field. So just like your roads, right? So there are patches, the contractor comes and fill it with something, what you call, gravel and tar, and then after that he uses road roller, and that's done. That's a planing. Okay, so this in case of planing operation, so if this is the, so it's already some field drains are here. Okay, some field drains are here, and you identify some patches, and then probably you may use the land leveler or land planer or land plane to be keep the original grade of the soil, or the planing operation can be done using this. So topography of the land surface is not going to be changed in this case, but the previous case you are going to change the topography. In this case, no topography is going to be changed, right? Topography of the land will be same. So the basically in this smoothing of land surface by eliminating minor depressions, what we did here. Okay, so the next is the layouts. So these are this is what we are talking about, surface drainage system. In surface drainage system, basically these three operations we need to do before going for the design. Okay, first you go and check whether the field is leveled or not, or what is the land slope and all those things. If it is not leveled, probably you need to use these three operations. And then once it is leveled, so now we have to think whether what kind of layout we need to plan. So there are, in case of surface drainage system, there are two types of layouts. One is random field drainage system, and then the other one is parallel field drainage system. Okay, so this is a surface drainage system layouts. So one is a random field drainage system. So in case of random field drainage system, suppose if this is the field and you found some, the wet spots, here wet spot and here wet spot. So these are all wet spots. So in that case, in case of random field drainage, you're going to use these field channels. So to connect the field channels based on the slope, so you are going to collect this 1 to 2, 3 to 4, so like based on the slope. So you're going to connect these two, and again, connecting these two, or maybe connecting these two, and you will have a common lateral for this, and then you have the the main system. So this is the field system, the main system. So these are all like wet spots, mostly the depressions. So in this case, the field drains are randomly placed. Okay, so you're taking the water from here 1 to 2, and water from 3 to 4, and collectively we are conveying it to a lateral, and this lateral being connected to your main system. So like that, this is a random field drainage system. So this is applicable when there are number of large but shallow depressions in the field. And these field ditches, so mostly whatever the field ditches we are talking, so these are all open channels. So these are all open channels. All are open channels we are talking. Okay. And soil from the ditches can be used to fill minor depressions in the field. So in that case, so the soil from the ditches, so whatever you have these ditches, so that also can be, when you dig out these ditches, so whatever the soil you get, that can be used to fill these, so that the area of impoundment can be reduced. Okay, so you fill it, so at least some depressions can be leveled, but other depressions still that could be the depth can be reduced. in this case. All right, so the next is the parallel drainage system. The second is the parallel drainage system. So we are talking about the layouts. Okay, one is a random. So randomly you can connect all the depressions and convey the whole, the excess water to the main system. So similarly, the parallel field drainage system. So in this case, you have the, the parallel drains, field drains. Okay, so let's say this is the field, and you have a parallel. These are the ditches, parallel ditches. Or parallel drains. Okay, so let's say this is the field drain, right? So the water from so water will be, from this land surface will be flowing into this. Similarly, water from this will be flowing into this. Some portion will be flowing into this. So similarly, so then finally you are going to collect the water into this. Okay, so the parallel, because the drains are parallel to each other, right? So this is suitable for flatter or poorly drained soils like the clay soils that have numerous shallow depressions. Okay, and this is installed across the slope to break the field into shorter units of length and make it less susceptible to erosion. The issue with uh, uh, the the overland flow is it can carry the sediments. Okay, so that's why the field channels will be installed across the field slope. Installed across the field slope. In this case, if you see, so this is the field slope, right? So we are going to cut down the field slope by installing it in the field channel, right? So this is the most effective method for surface drainage system. And the one characteristics you can see, the ditches are parallel to each other. That's why we call parallel drainage system here. Okay, and the next is the subsurface drainage system. This is all. So only two layouts we would see in case of surface drainage system. So one is random field drainage system, and second is parallel field drainage system. Whereas in subsurface drainage system, so in this, the characteristics for this subsurface drainage system could be, so the characteristics could be like the installation of drain pipe. So subsurface drainage system, you would see the deep ditches and tail pipes. Okay, so whereas the surface drainage system, shallow ditches, mostly the open ditches you can see. Whereas in subsurface drainage system, or deep ditches or tile drains or pipe drains, you could say. So the characteristics here, the pipes could be the way the pipes could be installed. Okay, so one could be like the singular pipes, the singular pipe drainage. So we're talking about the pipes installed subsurface, okay, below the soil surface. Okay, singular pipe drainage or composite pipe drainage. So in case of singular pipe drainage, so all the subsurface, drain pipes are connected to open ditch. Okay, so that means in case of singular drainage system, suppose if you have a field, right? And suppose this is the subsurface pipe which is installed. I'm using dashed lines because it is hidden, right, in the surface. And okay, so suppose this is, let's say, this is a field drain. It's a field. So this is basically pointing outside the main drain. Okay, so there you get the water. Okay, so this is the, let's say this is the pipe drain, and this is the open ditch, right? So in case of singular pipe drainage system, so the pipe is open to the atmosphere. The discharge of the pipe, or the discharge of the subsurface drainage uh, will be, you know, sorry, to the open ditch, right? To the open ditch. So that means, so this is a singular call. This is called a singular pipe drainage system. Whereas in composite pipe drainage system, so the discharge from the individual pipes are going to be, so another pipe. Okay, it's not open ditch, but it is a pipe. So let's see that one, how it looks like. So in case of composite system, so you have the pipe. So this one. So this is the, yeah. So this is, let's say this is the field. This is the tile drain. This is the tile or pipe drain. And this will be connected to, so like, let's say this one. So instead of open ditch, you will have a pipe. So similarly, you have another pipe. Okay, so this is also trail drain, and this is, let's say this is a collector drain. This is a collector drain. So here you would see the T-shaped joint where it can connect both the things. So like if you see, this is kind of a T-shaped joint. So it will be like this. So again, it will be like this. Okay. So water which is coming from this one. Okay, so this one is a tile drain, and this one is collector drain. Okay, both pipes are together. Both pipes are connected here to the hole. So water from the collector tile drain will be collected to a pipe drain. Sorry, collector drain. That's the pipe again. Whereas in singular pipe drainage system, the water from the tile drain will be collected to an open ditch. In case of composite drain pipe, so the water from tile drain will be collected to another, a pipe. Okay, so that's the difference. And in case of subsurface, so layouts, if you see, so layouts. So the two layouts we discussed in surface drainage system, they are common. So still, I mean, they are going, we would see the same terminology here, like a random field drainage system. Okay, and then parallel system. And in addition to that, the third one is a herringbone system. So these three layouts, you would see one is random system, second is parallel system, And then third is herringbone system. So herringbone is kind of a fish bone. So let's see one by one. In case of random system, yeah. So in random system, so you will have the patches of land where you need to collect the water. So let's say you have one patch here, one patch here, there's one patch here, there is another patch here somewhere, and let's say there's another patch. We have four patches. So you can collect here to here, okay, and then from let's say here, and also collect from. I mean, this is this not supposed to be definitely what I'm doing, but you know, I just want to explain how it looks like, how to collect. So from here, let's say from here, would be completely different, but and here you would see the open drain. This is the open drain where you collect all the water here. Is connected. So this is the wet spot, and this is also wet spot. This is also wet spot. This is the wet, and this is the wet. Okay. Yeah. So water will be collected from here, similarly from here, and from here, and then this is the open ditch. So let's go from here. So in case of random system, this is suitable for undulating or rolling land that contains isolated wet areas. Okay. And you can also, see the main drain is usually placed in the swales. The laterals in the pattern are arranged according to the size of the isolated wet areas. See, all the laterals, what we are showing here, may not have, same diameter, right? The laterals. So based on the size of the wet spot, the collection, the pipe diameter would be designed. So the laterals may be arranged in parallel or herringbone pattern. So generally this we call this is a herringbone. Okay, this is a herringbone pattern. So it could be like a parallel drain. So here you see the parallel drains here or herringbone. Okay. So I mean you would see the both random parallel herringbone system in this random system. Okay. And then the next is uh, parallel system. So this is for subsurface drainage system we are talking about. Okay, in parallel system you have all these field channels, or here we call the pipes, parallel pipes or tiles. So they are parallel to each other. Okay, and then you have a collector drain in between. This is a collector. And this is the field drain. So don't confuse with field drain to be always open ditch. So field drain is a common term. So it could be like open ditch or pipe. Okay, field drain. Similarly, the collector drain. So you will get the water and then dispose the water like this, using collectors. So field range joins the collector at right angle. That's the identity if you see. Okay, the laterals in the pattern, there may be space, at any interval. It may not be, the interval may not be, the same. So the interval from here to here could be different from interval from here to here. So since you are talking about, the larger field areas, the soil type could be, different within the field system. So you may have to go for different, spacings. So the variations of this pattern are often combined with, others. So sometimes, the patterns, so sometimes, so like here you have the spacing smaller, the spacing higher, larger in other places. Okay. So these combinations, you can also have the, singular system and composite system. These combinations you can have, you can also combine that. And the third one is the herringbone system. So in this, I already showed you the schematic, but in this basically the field drains. So join the collector. So if this is the collector, if this is the collector, so the field drains are going to join at some angle. So just like a fish bone, you see. So these are lateral, and this is the main. Okay. So water will be going in this direction, and finally it's been collected here. So, and the main basically is located on the major slope of the land, and the laterals are angled upstream on a grade, right? So whatever we're seeing is main. So this should be at the, where the maximum slope or major slope of the land is located. So this pattern is often combined with others to drain small or irregular areas. So this is basically to provide, extra drainage. If you need some extra drainage, so this herringbone system would be, used under, less permeable soils, for less permeable soils. So this particular pattern will help to, drain faster in less permeable soils. So the disadvantages here is this causes the double drainage and cost more than the other patterns because it contains, many joints. So here you see the lot of joints. Okay, not only here, then after that you will see, the field channels, all those things. So since it contains many junctions and intricate patterns, so definitely, it involves some cost. Okay. And the other last point is the combination of drainage systems. So every time the single drainage system may not work, like surface or subsurface drainage system. So sometimes you may have to combine the surface and subsurface drainage systems. So in case number one, so you are planning a wet food crop with a dry food crop. So the wet fruit in the sense rice, right? So rice crop requires, most of the time standing water. Dry food crops like maize, cotton, so that requires, a lot of, the soil should be aerated very well in this case. So in both cases, if you are planning like a crop rotation, like a rice rotated with dry food crops like maize and cotton. So in that case, you may have to use the combination of surface and subsurface drainage systems, because surface drainage system will be good for rice crop, whereas subsurface drainage systems will be good for maize crop, maize or cotton crop. Okay, so that means you have the rice crop here, the field, and the adjacent field you may have, the wheat, maize or wheat or any wet food crop, sorry, dry food crop or cotton. Uh, so in this case, suppose suddenly there is a rainfall happened. Okay, so the excess water from the rice to be removed, you know, using surface drainage system. Whereas from maize, you have to use the subsurface drainage system. So this removes the excess water, and this removes the water from subsurface root zone and removes the salts. Okay, so you would see the combination of surface and subsurface drainage systems here. So in the other case, the areas with occasional high intensity rainfall. So the second case, you would see the areas with high intensity rainfall. So that is greater than 50 mm per day. So if you have this, which causes surface ponding, even when a subsurface drainage system has been installed, because a lot of water is happening in a short period of time. So this pattern is often combined with other to drain small irregular areas. So in these situations, if we have surface drainage system, so suppose an area contains subsurface drainage system, and there is all of a sudden there is a huge rainfall. So in that case, the subsurface drainage system may not be effective. So you may have to go for surface drainage system, also combination of surface subsurface drainage systems. So uh, so areas with high intensity rainfall that has subsurface drainage system, it's a surface drainage system also. Okay. All right. So I'll stop here. If you have any questions, so let me know. Otherwise, on Wednesday, we'll be covering the drain pipe and some hydraulics, groundwater hydraulics, so that we can use some equations to design the spacing between the drains. Okay.
Sir, when we are studying the subsurface drainage system, firstly you introduce the singular pipe drainage and composite pipe drainage, and then you told about the layouts, random system, herringbone system, and I guess one more,
Herringbone.
parallel system. So sir, how are these two different? Like the layouts and what you mentioned earlier, singular pipe drainage and composite pipe drainage.
So the layouts. Okay. So layouts are the layouts. So what is happening inside the layouts is whether you singular or composite. Do you understand? So for
Okay.
example, uh, you have parallel system, right? So parallel system, all the drains are parallel. Okay, and that is I mean, all the parallel systems are, I mean, parallel uh, pipes are connected to a lateral. Let's say this is the lateral. This is the pipe. So how are these are connected? Whether this is a singular or composite, like this. Okay.
Okay, sir.
Yeah. So the layout will be there. Layout, we were not going to change the layout, but how these, field system or the field drains and collector or, they join. So how they are joining? That's using a singular system or composite system. So in case of, in case of singular here, the lateral could be like open ditch. So this could be open ditch in case of singular, and this will be a pipe in case of composite. Okay.
Okay, sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, can you upload the notes in the file section of the team?
Uh, Actually, so the notes means I have this one, and in
Yes,
addition,
yes, sir.
yeah. So this is the notes. So do you want me to upload this?
Yes, sir. The class note itself.
Okay, I can do that.
Thank you, sir.
Any other questions? So that means you're okay with the exams, right? Offline exams, or any issue? Okay. See you all on Wednesday.
Yeah, thank you, sir.
Yeah.
Thank you.